Hello, I'm Dmitry Shubin, and I'm a senior data scientist at Lawson Labs Sick Kids Hospital. And today I'm glad to present our work, time-efficient labeling framework for biological waveform data using semi-supervised learning and interactive visualization. Any supervised biological waveform classification model requires a decent amount of annotated data by clinical experts. However, clinicians are very busy, and even collecting of the mid-sized dataset usually requires hundreds of hours of monotone work for them. To address this problem, we propose our time-efficient labeling framework. It includes following procedures. First of all, we pre-train the feature representation deep neural net on unlabeled data. And then once we generate the record for the labeler, we also generate embeddings using this model. After that, based on those embeddings, we propose the most diverse segments for the labeler. And after getting several initial labels of the entire record, our ML model trained on the top of those embeddings is starting to generate label proposals that the annotation expert is able to accept or reject, and therefore reducing the amount of time spent on the manual annotation. As the pilot project, we have selected the AKG classification of the junctional ectropic tachycardia, or JET. We have prototyped our waveform visualization app and already provided labels for 13 patients or 26 hours of AKG in total. We also prototyped the semi-supervised labeling engine. We pre-trained the WaveNet autoencoder, and as you can see on the picture on the right, it provides a pretty clear separation of the JET and non-JET clusters. We used the k-means clustering as the diversity criteria and KNN algorithm for the final classification on the top of those embeddings. As the result, we were able to provide label proposals for 93% of the data for each record with 80% F1 macro score. Assume that we have only 7% of the data pre-annotated by the annotation expert. In our work, we proposed a novel framework for the time-efficient labeling of biological waveforms. Future development will include the integration of the ML engine into the visualization app, as well as the additional research into the optimal strategy for unbalanced records. Thank you so much for your attention, and see you on QA session.